So this is sort of a part two of the walking analysis overview. So this is a brief overview looking at the angular portion of the analysis output. So again, as you can see the dashboard with some of the tools across here, we're on the walking analysis. We'll cover those other aspects later. What you do is you click on Angular, and it's going to change the profile a little bit. As you can see, the first thing that we see across the dashboard are the pronation supination angles, also called pronosupination. So this is the angular orientation of the foot as it comes into ground contact, through contact stance phase, and into the toe off. So remember that the sensor is just below the navicular, and this is going to give us the orientation of the mid to the rear foot during that stance phase. So we can see that we heel strike at negative 13.6 degrees and negative 14.9 degrees on the left and the right feet respectively. And so a negative orientation means that it's going to be a heel inverted position or sort of a supinated position, which makes sense because that's the normal orientation of the foot upon heel strike. You'll also notice the coloration, so it's in green, and as we mentioned in the general view, that green is within the normative data of that particular patient's demographic. And then we can see over here that we've got that gold color, which is in the end of the spectrum within the normal, either high or low. And then you can see if we go all the way across here to the right, we see that we've got 5 degrees, so now it's a positive angle. And so that means that in red, it's outside of what's considered to be the normative data. So we can look at a little bit more specific graphical representation of this. You're just going to click on the advanced, scroll down just a little bit. So now we get to see the entire graph of the foot as it moves through the orientation of the stance phase. What you'll notice here in the green is that's referred to as the corridor. So that is a normative pathway or trajectory that's been determined specifically with this system in the evaluation of supination and pronation. So again, what you can see here is you can put your cursor over the dot. So that's on heel strike, and you'll notice that it represents the same number as in the upper left-hand corner there, which is the negative 13.6 degrees. But the other thing that you'll notice too is that there's a min and a max. So that's actually the standard deviation of the mean of that negative 13.6 degrees. So that's represented here in these two grayed out lines on either side of the middle black line, which is going to be the mean. So you actually get a nice graphical representation of the standard deviation in the corridor. It really should never be completely tight, and it shouldn't be too wide either. That's indicative of such a low standard deviation that someone doesn't really have the capacity necessarily to respond or react to a rapidly changing environment, sometimes seen in really chronic conditions or pathologies. And then likewise, when it's really, really wide, that's usually indicative of some sort of motor control effect or a lack of control as a result of some stimulatory action, such as if someone is in pain, they're probably changing the way that their foot is moving through the stance phase pattern, and oftentimes we see a wider standard deviation. So as I mentioned, that upon heel strike, there's going to be an inverted heel as we go and we put the rest of the foot down and we get into foot flat position, right? So this is your normal stance phase position where the foot is in complete contact with the ground, so it moves into more of a pronated position of the overall foot, and the heel moves into a more neutral position, so it lessens that negative angle and goes towards a heel everted position, not necessarily everted, but towards that that angulation. And then we see as we start to lift off the heel, it might move a little bit more into that heel everted position. It may not break that 0 degree mark, but oftentimes it will once you get into the toe off position. So we see that the heel actually moves into a relatively normal position as we transition into that first and second ray. If we look over here to the right, we do see that we do get a much larger translation, and it goes into a very positive angle, meaning that the heel is now everting past the neutral position into a positive angle. So it's actually positioned much more laterally, or eversion in terms of that position. So as we can see here in red, that's considered a outside of the normal standard that we've established right here. Now that's called absolute. So it's showing you the time frame in milliseconds in each one of those phases. You can click on relative, and it'll show you the percentage of time overall, taking the overall time spent in the foot contact time and breaking it down into the relative percentages. You'll also see that it neutralizes and it puts the full foot in contact with the ground as a 0. So that might give some people a little bit different orientation. Scroll down a little bit further and we see what's referred to as the foot progression angle. So we get 2 bits of data from this. What we're going to get is, if you imagine a sagittal plane as the trajectory, if you were walking or your patient is walking, the angulation, okay, that angle that we see in the foot progression angle is actually the angle of external rotation or deviation of the toes as they're pointing outward. So a positive angle is going to be represented as an external angle, and that numerical value, typical average, is often between 8 and 15 degrees of that toe out or external rotated position as you move through that sagittal plane. Now we also get another bit of data, which is going to be the deviation laterally or medially, if someone had that sort of pathology, from that sagittal plane in sort of a circumduction from the hip. Now it's actually it's multiplanar, because it also is going to depend on how you're going to be flexing the knee, and in combination between knee flexion and rotating through the hip and pivoting that foot out. So the amount of deviation, and that's what you see up here, is this person deviated 0.6 degrees off of that trajectory completely in that sagittal plane. So some of the things you're going to take into consideration is if they are toeing out too much or not toeing out enough. Could be as a result of lack of dorsiflexion, or an increase or decrease in knee flexion, or some things to look at in terms of that angulation, but also the circumduction. So for example, if someone has a knee issue or inability to dorsiflex that foot, to be able to clear the ground, they're going to have to create a different trajectory to get that foot over the ground surface, and they may have to swing it out a little bit further through a strategy of using the hip and increasing that overall circumduction. And then we look over to the right here, and we have what's referred to as clearance and steppage. So clearance is actually the distance at which the foot is going across horizontally from the floor surface. So we see here that we have clearance at 0.9 inches and 1 inch. So that's considered to be within the normative spectrum. So it shouldn't be so low that people are scuffing their feet. And when it's too low, sometimes that's going to be indicative of someone who does not want to lift their foot up too high, which means that they could have a fear of falling, for example, or they're having some issues with the range of motion, and instead of dorsiflexing or lifting the foot or flexing the knee too much, we may see that as a co-commitment increase in the amount of circumduction or swinging that leg out. Also, you can sort of relate that back to someone with a really low clearance and probably a shorter stride length as well, and possibly an increased amount of contact time. And then we see, so this is the angulation at toe off and the attack angle at heel strike. So at toe off, there should be an angle of plantar flexion, which means that they are using the strategy of using plantar flexion, and we see that they're on the high ends of normal within here. And then we have the attack angle, which is going to be the heel strike, right? So that's the angle of the foot relative to the horizontal or the surface of the ground. Now that can be important again because if they are shuffling their feet, right, and they are not lifting their feet too much, it means that they're not going to be lifting up too far and reaching out. So there could be again that issue with a strategy where someone has a fear of falling, or they have an inability to completely perform knee extension. So it means they're not going to have as great a stride length, so they're going to have a smaller angle of attack, and or potentially something going on at the hip. Again, a tight hamstring could also limit that length of stride as well as minimize that attack angle that we see here.